Welcome to Eternal Earth Stories, where curiosity doesn't need to rush and wonder is given room to breathe. Tonight, the question that has followed humanity across centuries and across every culture returns to us again. It is a question as old as myth and as modern as a NASA press release. Are we truly alone? When we look up at the night sky, countless stars scatter across the darkness, but among them there is one that has always caught our eye. It glows with a faint, rusty light, steady and clear, rising slowly above the horizon as if keeping its own quiet vigil. This is Mars, the red planet. For as long as people have been watching the heavens, Mars has stirred feelings of curiosity, unease, and longing. It is close enough to see without a telescope, bright enough to stand out, and strange enough to remind us that not everything up there is cold and unreachable. Mars seems alive, even when we know it is not, or at least we think we know. Imagine standing on an open plain on a clear night, far from city lights. The sky stretches above you like an ocean of darkness. Stars shimmer like frost scattered across glass. And then, there, a point of red light, glowing faintly, its color different from the rest. Ancient peoples noticed it too. They gave it names, built stories around it, tied its movement to gods of war, desire, and fate. To them, it was not just another star. It was a presence, something significant. Today we know it as a neighboring planet, but the mystery has only deepened. For centuries, Mars has been the canvas for our questions about life beyond Earth. Even before telescopes showed us its surface, its wandering movement across the heavens set it apart. Unlike the stars that never shifted, Mars moved, wandering slowly, predictably, but undeniably alive in its path. The ancients read omens in its dance. Modern astronomers measured its orbit. Science fiction writers filled it with cities, canals, and beings who might be watching us even as we watch them. The fascination has never left us. Now, in the age of space exploration, the planet is no longer just a red dot in the sky. We have sent machines across millions of miles to touch its soil, to taste its air, to send back photographs more detailed than anything we imagine. And in those images, in those measurements, there are whispers, quiet signs that Mars may hold the memory of life. Not intelligent beings with towers and spaceships, but something smaller, quieter, older, microscopic life. Life that could have existed long before us, or life that may even linger still. The idea changes everything. If we can find even the faintest trace of life on Mars, it tells us that life is not a miracle limited to Earth. It tells us that biology might be woven into the universe itself. The question of whether we are alone moves from philosophy into science, from dream into data. That is why NASA's discoveries matter so much. They are not just rocks and soil samples. They are clues in the greatest investigation humanity has ever attempted. But before we follow those clues, before we trace the evidence NASA has found, we need to pause and truly look at Mars. To understand why this world has always been so important, we must first see what it is and what it has been. Mars is the fourth planet from the Sun, orbiting just beyond Earth. It is smaller than our world, with a diameter about half of Earth's and a surface area roughly equal to all the land on our planet. If you spread out Earth's continents and placed them side by side, you would have Mars. That scale alone makes it feel familiar, almost like a little brother to our world. But the more closely you look, the more alien it becomes. The color that shines so distinctly in the night sky comes from iron oxide, rust, spread across its surface. Dust storms sweep that iron-rich soil across plains and valleys, painting the planet in shades of orange and red. Its thin atmosphere lets the sunlight fall harshly, leaving shadows sharp and skies a pale butterscotch instead of blue. The air is mostly carbon dioxide, thin and cold, impossible to breathe. At night the temperature plunges, colder than the most brutal winter on Earth. Yet despite these harsh realities, the planet carries scars that tell a different story. From orbit, we can see vast channels cut into the ground, dry riverbeds that stretch for hundreds of miles. We see layered cliffs that could only have formed by sediment settling in ancient lakes. We see minerals that on Earth only form in the presence of water. These are not random marks, they are the planet's diary, etched into stone. They tell us that Mars was once very different, warmer, wetter, more inviting. Billions of years ago, oceans may have spread across its surface, rivers may have flowed through valleys, and rain may have fallen under a thicker sky. And where there is water, there is the possibility of life. This is the thought that has fueled generations of scientists and explorers. If Mars once had oceans, could it also have had biology? Could there have been a time when Mars and Earth were not so different? When both planets were alive with microbes, perhaps evolving side by side under the same sun? If so, what happened? Why did Earth flourish with forests, animals, and people, while Mars became a desert? Did life vanish there completely, or did it retreat underground, clinging to niches we have not yet uncovered? NASA's missions have been built around these questions. Each rover, each probe, has been sent not just to explore, but to search. We have looked for organics, for methane, for the chemical fingerprints that life leaves behind. The search has been cautious, careful, and slow. And yet the discoveries have been extraordinary. Every few years, new results hint at the same possibility. Mars was once habitable. It may even be habitable still, at least for the smallest and most resilient forms of life. This is not speculation alone. Consider methane, a simple gas. On Earth, most methane in the atmosphere comes from life, from microbes, animals, even human industry. On Mars, instruments have detected methane that rises and falls with the seasons, appearing in bursts, then fading. This is puzzling. Methane can also come from geological processes, but the patterns on Mars are strange, inconsistent, and not yet explained. Each detection is like a whisper. Something is happening, but what? Or take organics. In 2018, NASA's Curiosity rover drilled into ancient rocks and found complex organic molecules preserved in the Martian soil. These are not life themselves, but they are the building blocks of biology. To find them in rocks 3 billion years old tells us that the ingredients for life were present long ago, and they might still be present today. Even water once thought gone has revealed itself. Polar ice caps stretch across the Martian poles. In 2018, radar data suggested a lake of liquid water hidden beneath the southern ice cap, kept from freezing by pressure and salts. More recent studies debate whether it is truly liquid, but the possibility is enough to keep the search alive. All of these findings build a picture, not of certainty, but of possibility. Mars may not be lifeless after all. The story is not finished, the book not closed. Instead, it feels as though we are standing at the edge of discovery, holding fragments of a larger truth. The beauty of this search is not only in what we might find, but in what it means for us. To look for life on Mars is to hold a mirror to our own existence. It forces us to see how fragile life is, how rare and yet how stubborn. It reminds us that we are part of a larger universe, not the center of it. And so the question remains, the question that will not leave us. Are we alone? Each new clue from Mars suggests that the answer may be within reach. Not tomorrow, not next week, but soon enough that we may live to see it. For now we wait and we wonder. Mars glows in the night sky as it has for millions of years, and humanity watches with patient eyes. Somewhere in its dust, its rocks, its buried ice, there may be a record of life. Perhaps NASA has already found it, hidden in data still being analyzed, waiting for recognition. Perhaps the greatest discovery in human history is already in our hands, quietly waiting for us to understand. For as long as people have lifted their gaze to the night sky, Mars has been there, glowing faintly but insistently, a restless wanderer among the stars. Unlike the constellations that seemed frozen in place, this one small red light moved. It shifted steadily from night to night, sometimes rising high, sometimes lingering low, never fixed, never still. To early sky watchers, this movement was a puzzle and a sign. The heavens were supposed to be eternal, perfect, unchanging, and yet Mars drifted like a restless spirit. That motion alone was enough to earn it a special place in the imagination of humanity. In Mesopotamia, some of the first astronomers gave Mars the name Nergal, associating it with fire, plague, and war. Its red color spoke of heat, of blood, of violence. When they watched it cross the heavens, they believed it was a heavenly omen, a messenger of conflict or disaster. For them, Mars was not just a planet, it was a god, unpredictable and fierce. The Babylonians studied its cycles with great care. They kept clay tablets marked with astronomical records, noting the times when Mars appeared brightest, when it moved backward in the sky in retrograde, when it lingered near other stars. These observations were more than curiosity. They were tied to agriculture, kingship, and prophecy. Mars, they believed, had power over the fate of nations. The Greeks, inheriting knowledge from Mesopotamia, called the Red Wanderer Ares, the god of war. The Romans later gave it the name we still use today, Mars, their own god of battle and conquest. The name fit perfectly. To a culture built on legions and campaigns, a glowing red star that heralded war seemed an obvious celestial ally. When Roman soldiers marched, they did so under the protection of Mars. Temples rose in his honor, and the planet that carried his name was seen as a divine reflection of their martial spirit. In India, ancient Hindu texts described Mars as Mangala, a celestial being connected with energy, strength, and aggression. In Chinese tradition, Mars was one of the 5 stars associated with the 5 elements. Its red glow linked it to fire, and in their astrological system, it foretold upheaval, war, or sudden change. Across cultures separated by oceans and languages, the impression was strikingly similar. Mars meant conflict, passion, and danger, and yet it was not only feared. Sometimes it was revered. Some cultures saw in it a sign of vitality, of courage, of endurance. Its unpredictable path made it seem alive, like a heartbeat in the sky. When you see something that defies stillness, you cannot help but imagine intent behind it. To ancient stargazers, Mars was not just a distant point of light. It was a will, a presence. As astronomy matured, the picture began to change. Telescopes gave us more than just a red glimmer. By the 17th century, astronomers like Galileo and Huygens turned their lenses toward the planet and began to sketch what they saw. Huygens, in 1659, drew a dark triangular mark on Mars, the Syrtis Major Planum, that we can still recognize today. He also noticed that the planet seemed to spin, completing a rotation in about 24 hours, much like Earth. Suddenly, Mars looked less like a god and more like a world. The discoveries multiplied. By the late 19th century, Italian astronomer Schiaparelli announced that he had seen canali, lines crisscrossing the Martian surface. The word meant channels, but it was mistranslated into English as canals. The difference was explosive. A channel might be natural, carved by rivers or glaciers. A canal suggested design, intention, intelligence. If Mars had canals, then Mars might have engineers. The idea ignited the imagination of the public. American astronomer Percival Lowell became one of its greatest champions. He built an observatory in Flagstaff, Arizona, and spent night after night mapping the supposed canals. He believed they were the work of a dying civilization, desperate to carry water from the polar caps across a dry world. To Lowell, Mars was not only alive, it was inhabited. His books reached wide audiences and painted vivid pictures of Martians battling extinction with planetary-scale projects. Although later observations proved the canals to be optical illusions, the seed had been planted. Mars became the stage for one of the greatest what-if stories of modern times. Science fiction seized on the idea and never let go. In 1898, H.G. Wells published The War of the Worlds, where Martians invaded Earth with terrifying machines, overwhelming human cities with heat rays and poisonous smoke. It was fiction, but it tapped into a fear that felt real. If we were not alone, what if our neighbors were stronger or hungrier? In the early 20th century, pulp magazines filled with tales of Martian princesses, brave explorers, and alien landscapes. Edgar Rice Burroughs wrote A Princess of Mars, sending readers to a world of strange creatures and desert kingdoms. Mars became a mirror for our own hopes and fears. The unknown frontier, the exotic other, the dream of contact. Radio and film carried the fascination further. In 1938, Orson Welles' radio adaptation of The War of the Worlds was so convincing that some listeners believed an invasion was truly underway. Later, Hollywood filled screens with visions of Mars, sometimes terrifying, sometimes romantic, often reflecting the anxieties of the time. During the Cold War, Mars was depicted as a battlefield of ideology. In more recent decades, it became a canvas for survival stories, from The Martian to countless documentaries exploring colonization. Why Mars, though? Why not Jupiter or Venus or Saturn with its breathtaking rings? Part of the answer lies in visibility. Mars is the only planet beyond Earth where the surface is clearly visible from afar. Jupiter and Saturn are gas giants, vast, majestic, but without a solid ground to imagine walking upon. Venus is cloaked in thick clouds, hiding its surface until modern probes revealed it to be a hellish wasteland. But Mars, even through early telescopes, showed dark patches, polar caps, changing seasons. It looked like a place, an actual landscape, a world that could be touched. Another reason is scale. Mars is not too big, not too small. Its day is close to ours, its tilt creates seasons like ours, its valleys and mountains resemble Earth's geography but stretch to extremes. Olympus Mons, the largest volcano in the solar system, towers 3 times higher than Mount Everest. Valles Marineris, a canyon system, would stretch from New York to Los Angeles. These features make Mars feel both familiar and extraordinary. It is alien, but in ways we can still relate to. And then there is the color. That rusty glow sets it apart from every other wanderer in the sky. It demands attention, a spark of strangeness that has always made people wonder. Even without telescopes, without rovers, without science fiction, that glow alone is enough to mark Mars as special. Without talk, without silence. The club lock, without silence, without special. When NASA and other agencies began sending spacecraft to explore the solar system, Mars naturally became one of the first destinations. The Mariner flybys of the 1960s gave us our first close-up images. They showed a barren, cratered surface, disappointing to those who still dreamed of canals and cities. But even in that disappointment, a new fascination began. The more clearly we saw Mars, the more questions arose. This is why Mars has always held our gaze more tightly than other worlds. It is close enough to study, strange enough to surprise us, and familiar enough to imagine ourselves there. For ancient stargazers, it was an omen of war. For early astronomers, it was a puzzle of canals and markings. For science fiction, it was a stage for dreams and fears. And for modern science, it is the most likely place beyond Earth to reveal the answer to the question that will not leave us. As we continue to look at Mars, not as myth, not as fiction, but as a real, complex planet, the fascination only deepens. It has carried our stories for millennia, reflecting our fears and our hopes. Now, with every new mission, we come closer to seeing the planet not just as a symbol, but as a place that may hold the truth about life itself. If you set aside the myths and the fiction, if you strip away the gods of war and the imagined canals, what remains is a planet waiting to be understood on its own terms. To see Mars not as a symbol but as a world is to peel back layers of story and expectation and to face what is truly there. And what is there is both stark and astonishing. Mars circles the Sun at an average distance of about 228 million kilometers, nearly 1.5 times farther than Earth. Its year is almost twice as long as ours, 687 days. But its day, or sol, is surprisingly familiar, just a little over 24 hours. This rhythm makes Mars feel less foreign than it might. A sunrise and a sunset there would follow almost the same tempo as on Earth, though the colors would be different, and the air would taste like nothing we could breathe. It is made mostly of carbon dioxide, with traces of nitrogen and argon. Without a protective thickness, the sky cannot scatter sunlight the way ours does. Instead of a brilliant blue dome, the Martian sky glows in shades of peach and tan, sometimes deepening to butterscotch near the horizon. At sunset, the colors reverse. The horizon turns blue, while the rest of the sky remains dusty red, a trick of scattered light in the thin air. It is beautiful, but it is not welcoming. Temperatures swing wildly. Near the equator, in summer daylight, it can climb just above freezing. At night, even in the same region, it plunges to 70 degrees Celsius. Near the poles, it falls much lower, cold enough to freeze not only water but carbon dioxide, forming caps of dry ice. With so little air to hold warmth, the planet radiates heat into space quickly, leaving nights bitter and still. Winds sweep across plains and valleys, carrying fine grains of iron-rich dust. Sometimes these winds build into planet-wide storms that last for weeks, veiling the surface in a haze that even blocks sunlight from reaching rovers and landers. At other times, the winds etch ripples into dunes, carving delicate patterns that shift slowly over time. To watch these storms from orbit is to see an entire world blur, then clear again, as though exhaling. The surface itself is a study in contrasts. Northern Mars is lower, smoother, with vast plains that stretch for thousands of kilometers. Southern Mars is older, higher, and battered by craters. This division is called the Martian dichotomy, and it is one of the planet's great puzzles. Why is one hemisphere ancient and rugged, while the other is young and flat? Theories suggest giant impacts, internal processes, or both, but the answer remains uncertain. Across the planet stand features so vast they challenge imagination. Olympus Mons rises more than 21 kilometers high, the tallest volcano in the solar system, 3 times the height of Mount Everest and wide enough to cover the entire state of Arizona. Its flanks slope gently, built by countless eruptions of lava flowing across the surface in slow waves. It is so large that if you stood on its summit, the curve of the planet would hide its base from sight. To the east stretches Valles Marineris, a canyon system 4,000 kilometers long and up to 7 kilometers deep. It dwarfs the Grand Canyon, a scar across the face of Mars that could span nearly the entire width of the United States. Scientists believe it formed from tectonic stresses as the crust stretched and cracked, perhaps widened by water or landslides long ago. Looking at it is like staring into the planet's bones. Scattered across the surface are impact craters, reminders of a violent history. Some, like Hellas Basin, are immense, over 2,000 kilometers wide, carved by asteroids that struck with unimaginable force. Others are smaller but no less telling. They speak of a world shaped by both fire and impact, by lava and stone from the sky. For all its violence and desolation, Mars also carries signs of gentler times. Orbiters have photographed valleys that twist and branch like riverbeds. Some end in fan-shaped deltas, where water once slowed and spread, dropping sediments as it entered a lake. Minerals such as clays and sulfates, which form only in the presence of water, lie scattered across ancient terrains. These are not coincidences, they are evidence. They tell us that Mars was wetter, warmer, and more familiar than it is now. Billions of years ago, scientists believe, Mars may have had a thicker atmosphere, strong enough to trap heat and keep water liquid on the surface. In those days, lakes may have filled craters, rivers may have run for hundreds of kilometers, and perhaps even an ocean may have spread across the northern lowlands. The idea of a Martian ocean remains debated, but shore-like formations and deposits hint at its possibility. If true, Mars may once have glittered with waves and storms, a blue world under a young sun. To imagine this is to see Mars not as barren, but as a sibling to Earth, following a different path. Around the same time that life on our planet was beginning, simple, microscopic, fragile, Mars may have been a place where similar sparks could have taken hold. The chemistry was there, the water was there, the energy from the sun was there. Conditions that make life possible were not unique to Earth. They were shared across worlds. What changed? Why did Earth continue to thrive while Mars dried and froze? One answer lies in size. Mars is only about half the diameter of Earth, with less gravity to hold onto its atmosphere. Over time, solar winds stripped gases away, thinning the air until it could no longer keep the planet warm. Without protection, surface water evaporated or froze, leaving behind only traces. Another answer lies in the planet's heart. Mars lacks the global magnetic field that shields Earth from charged particles streaming from the sun. Without it, radiation bombarded the atmosphere, hastening its loss. These processes did not happen overnight. They unfolded over hundreds of millions of years, slowly transforming Mars from a world of rivers and lakes into a desert of rock and dust. Yet the evidence of that earlier era remains etched into stone, waiting for us to read it. The presence of water, even in the past, is more than a geological curiosity. Water is the medium in which life as we know it begins and endures. On Earth, every known form of life depends on it, from the simplest microbe to the largest whale. Where water exists, chemistry dances, molecules join and possibilities open. To learn that Mars once had water is to learn that it once had potential. Today, water still exists on Mars, though locked away. Ice lies just beneath the soil in many places, revealed when landers dig shallow trenches. The poles are capped with layers of frozen water and carbon dioxide. And there may be, beneath layers of ice and rock, reservoirs of salty liquid that endure in the cold. These are not oceans you could sail upon, but they are reminders that Mars is not entirely dry. It is a world that hides its water, but does not deny it. The thought lingers gently, like a quiet echo. Where water once flowed, life may have bloomed. Perhaps it was simple, microbial, clinging to the edges of lakes or streams. Perhaps it left chemical traces still buried in ancient rocks. Perhaps it survived longer than we imagine, even into the present, deep below the surface where warmth from the planet's interior still seeps. Every rover, every orbiter, every mission has been drawn by this possibility. We do not study Mars only to map its mountains or measure its atmosphere. We study it because it is a mirror. It shows us another path a world like ours might take. It shows us what happens when conditions change, when atmospheres thin, when water retreats, and it shows us that life, if it ever arose there, would have had to adapt, endure, or vanish. As we uncover more about the Red Planet, we are not only unraveling its past, we are asking a deeper question. What does it mean for a planet to be alive? Earth hums with biology, reshaping air and soil. Mars seems silent, but silence can hide much. Rocks hold memory, ice remembers, dust whispers of rivers that no longer run. In studying Mars, we learn to listen differently, to pay attention to subtle marks left by time and by nature. The planet's story is not one of simple desolation. It is a story of change, of warmth and water, of loss and survival. It is a reminder that worlds are not fixed but dynamic, shaped by forces both gentle and fierce, and in that story, we catch glimpses of our own. As telescopes improved and human eyes sharpened, Mars shifted from a faint red light in the night sky into a world with visible features. For centuries, it had been only a glow, but in the 19th century, something remarkable began to happen. Astronomers could finally make out details on its face. And what they thought they saw would set the stage for one of the most enduring mysteries in planetary science. In 1877, during an especially favorable opposition when Mars was unusually close to Earth, Italian astronomer Giovanni Schiaparelli trained his telescope on the planet. What he recorded was startling. Across its surface he saw lines, long, thin, straight markings that seemed to connect darker regions. He called them canali, an Italian word meaning channels. His intention was neutral, simply descriptive, but when the word was translated into English, it became canals, and with that single choice of word, a flood of imagination burst forth. Canals implied design, intention, engineering. A channel could be carved by water, by natural forces. A canal suggested intelligence, builders, purpose. To Schiaparelli, they were curious features worth studying. To the world, they were signs of Martians. American astronomer Percival Lowell became one of the most passionate advocates of this idea. Fascinated by Schiaparelli's maps, he built his own observatory in Flagstaff, Arizona, specifically to study Mars. Night after night, year after year, he sketched what he believed to be an elaborate network of canals stretching across the Martian globe. To Lowell, this was no illusion. He was convinced that Mars was inhabited by a civilization struggling against a changing world. In Lowell's view, the canals were vast irrigation systems, designed to carry water from the melting polar caps toward the equatorial regions, feeding a parched planet. He described a dying world where intelligent beings fought to survive by building colossal structures across continents. His writings captured the public imagination. Newspapers printed his maps. Popular science magazines echoed his theories. For many, the idea of Martians was no longer science fiction, it was science. Even as some astronomers doubted the canals, the image stuck. The more people looked, the more they seemed to see. The human brain has a way of finding patterns, of connecting dots into lines, of turning smudges into structures. And so for decades the debate continued. Were these canals real, or were they illusions born of telescopes pushed to their limits and eyes eager for meaning? Regardless of the answer, the cultural impact was immense. Writers seized on the idea. H.G. Wells wrote The War of the Worlds, bringing Martians into literature and fear into the public imagination. Countless other stories followed, turning Mars into the natural home of alien civilizations. By the early 20th century, Mars was not just another planet in our solar system. It was our neighbor, and possibly our rival. As technology advanced, telescopes grew stronger, and photographs replaced sketches. By the mid-1900s, the canals faded from credibility. The higher the resolution, the less they appeared. What once looked like deliberate lines dissolved into natural formations. Lowell's Martians slowly retreated from science into the realm of myth. Yet the idea had done its work. It had placed Mars at the center of one of humanity's most compelling questions. Is life beyond Earth possible? The next great leap came not from Earth-bound telescopes, but from spacecraft. In the 1960s and 1970s, NASA's Mariner missions swept past Mars and sent back the first close-up images. Instead of cities and canals, they showed a surface battered by craters, swept by dust, and eerily empty. For some, it was a disappointment. The planet looked more like the Moon than the Earth. No obvious rivers, no vegetation, no monuments of alien engineering. The romantic vision of a living Mars seemed to vanish overnight. But science rarely ends with first impressions. The Mariner images were a beginning, not an end. They showed a real world, not an imagined one, and they revealed landscapes that raised new questions. Raters spoke of impacts, but valleys hinted at erosion. Dark markings shifted with the seasons, suggesting dust storms or surface changes. If nothing else, Mars refused to be simple. The true test came with the Viking program in the mid-1970s. Viking 1 and Viking 2 were twin missions, each consisting of an orbiter and a lander. They represented one of NASA's most ambitious efforts, designed not only to photograph and study Mars from above, but to touch down and analyze its soil directly. For the first time in history, human technology would conduct experiments on the Martian surface, searching for signs of life. The landings themselves were triumphs. Viking 1 touched down in July 1976, followed by Viking 2 in September. Cameras opened their electronic eyes and sent back images of a rocky, dusty landscape under a salmon-colored sky. For many, seeing those pictures was a profound moment. Humanity was looking not at an artist's impression, not at a telescope blur, but at the real surface of another planet. The science was even more daring. Each Viking lander carried instruments designed to test for microbial life. The experiments were ingenious for their time. One, called the Labeled Release Experiment, added a nutrient solution to Martian soil and monitored for gases that might be produced by metabolism. Another heated soil samples to look for organic molecules. Still another tested for changes in chemistry when exposed to different conditions. The results were confusing. The Labeled Release Experiment produced positive signals. Gases were released, suggesting metabolic activity. Excitement soared. Had Viking found life? But other experiments, particularly the search for organic molecules, found nothing. The contradiction left scientists puzzled. Some argued that the positive result was real, that microbes might exist in the soil. Others suggested chemical reactions driven by strong oxidants in the soil could mimic life signals without any biology involved. In the end, the consensus leaned toward the latter. Viking had not found life, but rather unusual chemistry that could be explained without biology. Officially, the verdict was negative. Mars, it seemed, was barren. Yet the story did not end there. The ambiguity of Vikings' results haunted planetary science for decades. The possibility that something unusual had happened in those soil samples, something that might hint at life, could never be fully dismissed. To this day, some scientists still argue that Viking may have stumbled upon microbial traces without recognizing them. What Viking did prove beyond doubt was that Mars was scientifically fascinating. The soil was chemically active. The surface was shaped by processes not yet fully understood. The images revealed dried river channels and layered terrains that hinted at a wetter past. The disappointment of not finding clear life was balanced by the thrill of discovering a planet far more complex than expected. Each discovery seemed to add to the mystery rather than resolve it. The canals had faded, but the real rivers of Mars were carved in stone. The dreams of civilizations had died, but the questions about habitability grew sharper. Was Mars once alive? Could it still be alive in some hidden niche? Viking did not answer these questions, but it made them impossible to ignore. In the years that followed, Mars would continue to draw spacecraft and scientists, each mission building on the last. The mystery had shifted. It was no longer about cities or canals. It was about chemistry, geology, and the possibility of life hidden deep in the dust. And so the search continued, carried forward by new generations of machines that would roll across the surface, drill into rocks, and fly through thin air. The Viking landers had given humanity its first real touch of the Martian soil. Their results were inconclusive, even frustrating, but rather than closing the chapter on Mars, they opened the door wider. A new generation of explorers would follow, carrying with them better instruments, stronger cameras, and above all, the patience to stay. The next great leap came not with stationary landers, but with rovers. Machines built not only to sit and sample, but to move, to travel, to wander, like robotic geologists across alien landscapes. These rovers would not simply observe a patch of dust. They would climb hills, cross valleys, and explore the planet the way a curious human might. And through their journeys, Mars would begin to reveal itself in ways Viking never could. In 2004, two identical rovers touched down on opposite sides of the planet. Their names were Spirit and Opportunity. Built by NASA's Jet Propulsion Laboratory, they were designed for a simple mission: 90 Martian days, or sols, of exploration. Each carried tools to analyze rocks, search for water minerals, and send back detailed photographs. Spirit landed first, bouncing to a stop inside its protective cocoon before unfolding its solar panels like the wings of an insect tasting sunlight. Opportunity followed, arriving on the other side of the planet in a small crater that gave it immediate access to layered rocks. Both began their work, and within weeks they had already transformed our view of Mars. Spirit found signs of past volcanic activity, basaltic rocks that told of fire shaping the landscape. Later, climbing a range of hills, it uncovered minerals that formed in the presence of water, evidence that parts of Mars had once been soaked in liquid long ago. Opportunity made an even more dramatic discovery. The rocks around its landing site contained small spheres of hematite, quickly nicknamed blueberry. On Earth, such formations often form in water. The layered sediments nearby told the same story. This was once a wet environment. From the very beginning, the rovers proved their worth, and they did something else. They endured. 90 sols came and went, and both machines were still alive. Months turned into years. Spirit climbed hills taller than its designers ever imagined it could scale. Opportunity drove across plains, covering more ground than any rover before it. Together they became symbols of persistence, explorers that refused to quit. Spirit eventually became stuck in soft soil in 2009. After months of effort, engineers could not free it. The rover kept sending data until it could no longer face the sun, and then it fell silent. Its mission had lasted more than 6 years, far beyond anyone's hopes. Opportunity carried on. It traveled more than 45 kilometers, exploring craters, plains, and ridges. It survived dust storms, winters, and the wear of endless driving. Finally, in 2018, a planet-wide dust storm smothered its solar panels. After months of listening, NASA declared the mission complete. Opportunity had lasted nearly 15 years, rewriting what was possible for robotic exploration. Their discoveries were profound. They confirmed beyond doubt that Mars had once been wet, not just in fleeting trickles but in sustained environments. The planet's past was not only cold and dry, it had places where water shaped stone, where conditions may once have been suitable for life. Spirit and opportunity gave Mars a history, and with it new reasons to wonder. The next step came with a larger, more advanced rover, Curiosity. Launched in 2011 and landing in 2012, Curiosity was a leap forward in both size and ambition. Weighing nearly a ton, it carried a full laboratory on wheels, equipped with instruments capable of analyzing the chemical makeup of rocks, drilling into them, and studying samples with remarkable precision. Its landing was itself a spectacle, using a sky crane system that lowered the rover by cables before flying away to crash at a safe distance. Engineers called it 7 minutes of terror, but it worked flawlessly, setting Curiosity down in Gale Crater, a basin chosen for its layered mountain, Mount Sharp, rising at its center. From the beginning, Curiosity's mission was clear: to determine whether Mars had ever been habitable. Within months, the rover delivered its answer. The rocks it drilled contained clays and minerals that form in neutral water, not acidic, not too salty, but fresh enough to have supported microbes. Later, in 2018, Curiosity made one of its most significant discoveries: complex organic molecules preserved in ancient sediments. These were not living organisms, but the chemical building blocks of life. They told us that the ingredients were present billions of years ago, when Mars was wetter and warmer. Curiosity also monitored methane in the atmosphere. It detected seasonal variations, traces of methane rising in warmer months, fading in colder ones. The source of this gas remains a puzzle. On Earth, methane is often produced by biology, though it can also come from geological processes. To see it on Mars, fluctuating with the seasons, is to encounter a mystery that has not yet been solved. Curiosity continues its climb up Mount Sharp, reading the layers of rock like pages of a book. Each stratum preserves a different era, from ancient lake beds to drier conditions above. Together, they tell the story of a planet that changed, and perhaps of life that could once have found a home there. And then came Perseverance. In 2021, the most advanced rover yet landed in Jezero Crater, a site chosen for one reason: it once held a lake, fed by a river that built a delta still visible from orbit. Deltas are excellent at preserving signs of past life, trapping sediments and organics in layers of mud and clay. If Mars ever hosted microbes, Jezero is one of the best places to find their traces. Perseverance carries instruments to study rocks in unprecedented detail. It drills, caches samples, and prepares them for a future mission that will return them to Earth, the first time Martian material will ever be brought home. It also carries microphones, letting us hear the whisper of Martian wind for the first time, and cameras that captured its own landing in stunning detail. Beside it came a small companion, Ingenuity, a helicopter no heavier than a house cat, designed as a technology demonstration. Powered by solar panels, with blades spinning 5 times faster than those of helicopters on Earth, Ingenuity faced the thin Martian atmosphere where flight seemed impossible. Yet it flew. What was supposed to be 5 test flights became dozens. It scouted ahead for Perseverance, photographing routes and revealing terrain. In doing so, it became the first aircraft ever to fly on another planet. Together, Perseverance and Ingenuity represent the newest chapter in Mars exploration. Their findings have already reshaped our understanding. Perseverance has confirmed the presence of ancient river sediments in Jezero Crater. It has discovered organic molecules in rocks that were once underwater. It has shown us that Mars is not simply a fossil of a dead world, but a place where the past still speaks, quietly, through stone. Each of these missions, Spirit, Opportunity, Curiosity, Perseverance, and even Ingenuity, has added pieces to a puzzle. The picture that emerges is not one of lifelessness, but of complexity. Mars was once wet. It had lakes, rivers, and possibly oceans. It had chemistry that could support life. Even today, it has processes we do not fully understand. methane that appears and vanishes, organics locked in rock, water hidden beneath ice. The rovers did not find cities, canals, or monuments. They found something more subtle and perhaps more profound. They found a planet with a story, a world that was once habitable, a world that still holds mysteries. And this leads us directly into the heart of the question. If Mars had water, if it had organics, if it had environments that could support life, then what traces remain? Have the rovers already glimpsed signs of life, waiting for us to recognize them? Or are they still hidden, buried deeper, awaiting the tools of future missions? Mars has always been a place of questions. The rovers have shown us that the planet once had water and that its rocks still carry the chemistry of habitability. But the deepest question remains untouched. Did Mars ever host life, even something as small as a microbe? And could it still, in some hidden corner, be alive today? One of the most puzzling clues lies not in stone, but in air. In recent years, instruments have detected traces of methane in the Martian atmosphere. Methane is a simple gas, but it matters because on Earth, much of it comes from life. Wetlands release it, herd animals produce it as they digest plants. Even tiny microbes buried deep underground breathe it out. Methane can also come from purely geological reactions, when water meets certain kinds of rock. But whatever the source, methane does not last long. Sunlight and chemistry break it down in just a few hundred years. If methane is there, it must be replenished by something happening now. Curiosity, NASA's rover inside Gale Crater measured methane rising and falling with the seasons. In summer, levels increased. In winter, they dropped. Other missions caught sudden spikes, brief, mysterious bursts that appeared and then vanished. The numbers were small, only a few parts per billion, but significant. Something on Mars is active. Something is releasing methane. Whether that something is geology or biology remains unknown. And so methane hovers as one of the most tantalizing hints, a whisper from a hidden process we have yet to fully understand. If life exists on Mars today, it is unlikely to live on the surface. The surface is harsh, frozen, blasted by radiation, swept by dust storms. But below ground, conditions could be different. Just a few meters down, the soil shields against deadly radiation. In briny pockets, salt can keep water liquid even in bitter cold. Ancient lava tubes may form caves with more stable temperatures. These quiet refuges, away from the hostile surface, are the most likely hiding places for microbes. We know this because of Earth's own extremophiles, organisms that thrive in places that once seemed uninhabitable. In boiling hot springs in Yellowstone, bacteria flourish at temperatures far above the boiling point of water. On the ocean floor, around hydrothermal vents, where minerals spew from Earth's crust, life thrives in total darkness, feeding not on sunlight but on chemistry. In Antarctica, microbes survive in frozen lakes buried under kilometers of ice. In the Atacama Desert of Chile, one of the driest places on Earth, tiny organisms live inside salt crystals, pulling moisture straight from the air. Each of these examples stretches our imagination of where life can exist. If microbes can survive heat that melts metal, or pressures that would crush submarines, or dryness that lasts for decades, then why not Mars? A cave beneath its surface might seem lifeless to us, but to microbes, it could be a sanctuary. A frozen cap of ice might look barren, but within its crystals there could be organisms waiting in dormancy, just as they do in Antarctica. And then there is the story of a rock. In 1984, scientists working in Antarctica found a meteorite, a dark fragment buried in the ice. When they studied it, they realized it was not just any rock. It had come from Mars. Long ago, an asteroid had struck the Martian surface, blasting debris into space. One piece drifted for millions of years before falling to Earth and resting in Antarctic ice. Inside it were tiny structures, so small they could only be seen with the most powerful microscopes. Some scientists thought they resembled fossilized microbes. There were also organic molecules and minerals that on Earth often form alongside life. When NASA announced these findings in 1996, the world reacted with astonishment. Could this be the first fossil from another planet? For a moment, it felt as if the greatest question of all had been answered. But science demands caution. Other researchers pointed out that the structures could be explained by natural chemical processes, that the organics could come from non-living reactions. The debate never truly ended. Some still believe the meteorite holds signs of ancient Martian microbes. Others see it as geology misinterpreted. Whether the rock holds fossils or not, its discovery carried a profound lesson. Pieces of Mars reach Earth. They cross space and bring with them the secrets of another world. And if a rock can carry those secrets, perhaps it can also carry life. Scientists call this idea panspermia, the possibility that microbes might travel between planets, protected inside stone, surviving the violence of impacts and the long journey through space. If true, it raises an even larger question. Could life on Earth and Mars be related? Taken together, these threads, methane in the air, microbes thriving in Earth's extremes, meteorites carrying whispers of biology, create a picture that is neither simple nor empty. Mars may not shout its secrets, but it murmurs possibilities. Maybe the methane is geology, but maybe it is biology. Maybe the meteorite is just chemistry, but maybe it is a fossil. Maybe the subsurface is sterile, but maybe it shelters a hidden biosphere. Each clue invites us closer, while refusing to give a final answer. Scientists remain cautious because the stakes are so high. To prove life exists beyond Earth, even at its smallest scale, would change everything. It would mean that life is not a rare accident, not unique to one planet, but a natural outcome when conditions allow. It would mean the universe is more alive than we have ever imagined. For now, we keep searching. Rovers sniff the air for methane, orbiters map ice deposits, drills dig into stone, and in laboratories on Earth, scientists study meteorites, trying to read their silent messages. Each effort brings us closer, each result sharpening the mystery. Mars has not yet given us a clear answer, but the clues are too strong to ignore. They are like footprints fading in sand, delicate, uncertain, but pointing towards something that may once have walked there. Every discovery on Mars has opened a door, but behind each door waits another question. The planet seems determined not to give us answers too easily. What we have found is enough to keep us searching, but never enough to close the case. It leaves us with possibilities, hypotheses that range from the scientific to the almost philosophical. Each one asks us to think more broadly, not just about Mars, but about our own place in the cosmos. One of the boldest ideas is called panspermia. The word simply means seeds everywhere, and it refers to the possibility that life can travel between worlds. The thought is simple. If rocks can be thrown from one planet to another, as we know they can, then perhaps microbes can hitch a ride. When an asteroid strikes Mars with enough force, fragments of the planet are blasted into space. Some of those fragments eventually cross paths with Earth, falling through our atmosphere as meteorites. We have found them in Antarctica, in deserts, even in fields where they were picked up by chance. If rocks can make the journey, the question becomes, could life inside them survive? Experiments suggest that the answer might be yes. Microbes on Earth can endure intense conditions, the vacuum of space, deep freezing, high radiation inside the protective shell of a rock. Some could potentially last for millions of years. If so, then life may not be bound to its planet of origin. It could spread, one collision at a time, carried like spores across the solar system. This leads to a daring question. What if life on Earth began on Mars? Billions of years ago, Mars was warm and wet, while Earth was still unstable, bombarded by impacts and struggling to cool. If microbes took root on Mars first, and if even a few were carried here on meteorites, then our entire history, every tree, every animal, every human, could be part of a Martian legacy. We would not simply be asking if life exists on Mars. We would be asking if we are, in some sense, Martians ourselves. It sounds like science fiction, but it is taken seriously enough to be tested. Researchers expose microbes to space, place them inside simulated meteorites, and study whether they can survive re-entry. Again and again, they find that life is tougher than expected. Panspermia does not prove that this is how life spread, but it shows that the journey is possible. If it happened once, perhaps it could happen again. Linked to this is another perspective, Mars as a failed Earth. The two planets began as siblings, formed from the same cloud of dust around the young sun. They share similar days, similar seasonal tilts, and a comparable age. But their paths diverged. Earth kept its thick atmosphere and liquid oceans. Mars lost both. The reasons are complex: a smaller size, weaker gravity, and the fading of its magnetic field. Without protection, solar winds stripped its air. The water evaporated or froze. What remained was a barren landscape, a frozen shadow of what might have been. When scientists call Mars a failed Earth, they do not mean it was destined to fail. They mean it shows how fragile habitability can be. Mars reminds us that planets are not guaranteed to stay alive. Even a world with rivers and lakes can dry up. Even a planet that once looked like Earth can change into something unrecognizable. In that sense, Mars is not only a place to study, it is a warning. It tells us that conditions we take for granted here, air we can breathe, oceans that endure, are not permanent. They must be maintained, or they can be lost. This view of Mars as a failed sibling adds weight to every discovery of water, every trace of methane, every meteorite with strange shapes inside. Each hint of habitability feels bittersweet. It tells us Mars could have been alive, and maybe it was. But it also shows us how fragile life's stage can be. Amid these possibilities, NASA and other space agencies communicate with great caution. The reason is simple. The claim that life exists elsewhere is extraordinary. It demands extraordinary evidence. A false signal, a rushed announcement, could damage trust and set back exploration. That is why, when Curiosity detected methane, NASA did not declare it as proof of biology. They said it was a mystery, something to be studied further. When Perseverance found organic molecules, they explained that organics do not automatically mean life. They are ingredients, but ingredients alone do not prove the recipe was used. This caution is not hesitation, it is discipline. The scientific method demands it. If we announce life too soon, we risk being wrong. If we wait too long, we may miss the chance to inspire. NASA walks a careful line, balancing curiosity with responsibility. And in a way, that restraint only adds to the mystery. It forces us to linger in uncertainty, to live with the question instead of rushing to the answer. So where do we stand? Some things we know with confidence. Mars once had water, flowing across its surface in rivers and lakes. It had a thicker atmosphere and a climate that could support habitability. It has rocks rich in minerals that on Earth form alongside life. It has methane in its air, though we do not yet know its source. It has organic molecules preserved in stone, and it has sent pieces of itself to Earth, carrying chemical signatures that still spark debate. Yet the greatest questions remain unanswered. We do not know if life ever started on Mars. We do not know if it still hides underground. We do not know if the methane we see is geological or biological. We do not know if meteorites carry fossils or illusion. The planet has shown us enough to keep us searching, but not enough to end the search. What we are left with is a story in progress. Mars is not a closed book. It is a draft written in dust, water, and stone. A story whose ending we have not yet read. And in that uncertainty lies its power. It keeps us looking upward. It keeps us wondering. It keeps us awake at night, imagining what secrets might still wait beneath the red surface. Mars has always been a mirror for human imagination. For centuries it was the backdrop for myths and stories, a stage where we projected hopes and fears. In recent decades, robotic explorers have transformed those dreams into data. Yet the next chapter is different. It is no longer about what machines can find, but about what humans might build. For the first time in history, we are not just asking if Mars can be explored, we are asking if it can be lived in. Colonization is a bold word. It suggests permanence, not just brief visits. And yet, that is the ambition some of the world's largest space agencies and private companies now carry. The most outspoken among them is SpaceX, led by Elon Musk. His vision is simple in outline but staggering in scale: to build a city on Mars with 1 million inhabitants, sustained by spacecraft carrying supplies and settlers across the void. He argues that humanity must become a multi-planetary species, both to survive long-term threats and to expand its horizon. The dream is enormous. Rockets larger than any built before, fleets of ships launching every time Earth and Mars align, greenhouses beneath domes, energy farms stretching across red plains. NASA's vision is more gradual. The agency has mapped out a series of steps, starting with the Artemis program, returning astronauts to the moon, then using the moon as a testing ground for the technologies needed to go further. Mars is on the roadmap, but the approach is cautious. First, long-duration missions in orbit, studying radiation and life support. Then, eventually, landing crews on the surface. Unlike SpaceX's sweeping promises, NASA speaks in decades, but the core goal is the same: placing humans on Mars. Other agencies and nations, from Europe, China, and beyond, also have plans, each with its own timelines and ambitions. Together, they weave a future where Mars is not just a destination for machines, but a world where human footprints are possible. But what would it actually mean to live there? Imagining daily life on Mars requires shifting our sense of normal. A Martian day or soul is close to ours, about 24 hours and 39 minutes. That makes time familiar. But the similarities fade quickly. Step outside without protection, and the thin atmosphere offers no breath, only carbon dioxide. The pressure is so low that unprotected water, even the moisture in human lungs, would boil away. Temperatures swing from tolerable near the equator at midday to bitterly cold at night, dropping far below freezing. Radiation, unblocked by a thick atmosphere or a magnetic field, constantly seeps down from space. To survive, humans would live in sealed habitats, structures that keep pressure, warmth, and air inside. Greenhouses would grow crops, but the soil would need treatment. Martian regolith, the dusty covering of the planet, contains toxic chemicals like perchlorates, which would need to be removed or managed. Water could be harvested from underground ice or recycled endlessly, every drop precious. Electricity would come from solar arrays or small nuclear reactors, powering systems that must never fail. A walk outside would not be a stroll but an expedition. Astronauts would wear pressurized suits, carrying their air on their backs. Each trip would be planned, each step tracked. Horizons would stretch wide and red, but always under the knowledge that a thin layer of fabric and metal separated life from death. The psychological challenge would be as real as the physical one. A crew would live in close quarters, isolated, with Earth a distant dot in the sky. Communication delays, up to 20 minutes each way, would mean no real-time conversations with loved ones. The settlers would have to build not only shelters, but a sense of community, a rhythm of life that could endure. Yet in these challenges lies the allure. For those who dream of Mars, the planet offers the chance to start anew, to build societies in miniature, to test technologies that could one day sustain humanity beyond Earth. What today seems harsh and barren could one day be home to the glow of greenhouses, the hum of machines, even the laughter of children born on another world. Still, these visions do not erase the unknowns. That is why the first crewed missions are not expected to look like colonies. They will be expeditions, limited in scope, designed to test survival. Astronauts will live for months, maybe a few years, inside habitats brought from Earth or built with local materials. They will study how bodies adapt to Martian gravity, about a third of Earth's. They will measure how radiation affects long-term health. They will practice using Martian resources, extracting water, producing fuel, creating oxygen. Most importantly, they will explore with human intuition something rovers cannot fully match. A trained geologist on Mars could cover in hours what a rover might take months to achieve. Humans could choose rocks on instinct, follow leads, and adapt in real time. They could search with curiosity, guided not just by instruments but by experience. And there is one goal above all: to finally answer the question of life. Machines have carried out experiments, drilled, and analyzed. They have found organics, water, and chemistry. But no machine has yet been able to say with certainty whether Mars ever hosted life. Human missions could dig deeper, explore more widely, and bring samples back directly. The return of Martian soil and rock to Earth would allow laboratories to search at levels of precision no rover can match. If traces of life are hidden, a human-led mission may be the one to find them. There is also a philosophical weight to the first footsteps on Mars. When Neil Armstrong stepped onto the moon, he spoke of a giant leap for mankind. When someone takes that first step onto Martian soil, it will carry not just symbolism, but permanence. The moon was a visit. Mars would be a beginning. Of course, the risks are immense. Rockets must be reliable. Life support must be flawless. The costs are staggering and the timescales uncertain. Some critics argue that robotic exploration offers better science at lower risk. Others question whether resources should be focused on Earth itself. These debates will not vanish. But the drive to explore, to push outward, is deeply human. It has carried us across oceans, into skies, and now into space. Mars is simply the next horizon. What emerges is a picture both daring and uncertain. SpaceX envisions fleets of rockets, NASA charts careful roadmaps, international partners lay plans of their own. The timelines differ, the details vary, but the direction is the same. Step by step, mission by mission, we are moving closer to a future where humans stand on Mars. And with that future come questions no robot can answer. What does it feel like to see a Martian sunset with your own eyes? How does it change someone to look up at Earth as a pale dot above a red horizon? What kind of stories will the first settlers tell, and what kind of societies will they shape? These are not just scientific questions, they are human ones. In the end, colonization is not about escaping Earth. It is about expanding perspective. To live on Mars would be to see ourselves differently, fragile, adaptable, and capable of reaching beyond what once seemed impossible. The plans are being drawn, the rockets are being built, the training is underway. The future of Mars is still unwritten, but for the first time it feels within reach. There is a reason the search for life on Mars captures us so deeply. It is not just about another planet, it is about us. For centuries we have looked up at the night sky and asked whether we are alone. The silence of the universe has always been overwhelming. But silence is not proof. The possibility that Mars once held life, or may still hold it, hidden beneath its surface, forces us to consider questions that reach far beyond science. What would it mean if we found proof? Imagine that in some crater, beneath layers of clay, we discovered fossilized microbes. Imagine that in a sample returned to Earth, under the lens of a microscope, we saw unmistakable evidence that life had once grown, divided, and died on another world. Even if it were nothing more than bacteria, the impact would be enormous. It would tell us that life is not a miracle confined to Earth. It is a natural consequence of chemistry, likely to appear wherever the right conditions arise. For centuries, humans thought of Earth as the center of everything. Then astronomy revealed we orbit the sun. Later we learned that the sun is one star among billions, in a galaxy that itself is only one among countless others. Each of these revelations humbled us, but each also expanded our view. To discover life on Mars would be another step in that progression, a reminder that we are not the measure of the universe, but part of its larger story. Even the smallest trace of Martian life would shift philosophy, religion, and culture. It would reshape how we think of creation, uniqueness, and destiny. The idea that biology could emerge twice in one solar system suggests it may be everywhere. The stars above us would no longer look cold and distant. They would look fertile. Each one might harbor planets where rivers once ran, where atmospheres once warmed, where something stirred and multiplied. But the discovery would also bring humility. If life can arise easily, then it can also vanish easily. Mars itself may prove the point. It may have once been habitable, even inhabited, and yet today it is barren. That arc is sobering. It shows us that life is fragile, tied to its environment. It warns us that planets change, climates shift, and nothing is guaranteed. In that sense, Mars is not only a place we study, it is a mirror. When we see its dry riverbeds, we are reminded of the importance of water here at home. When we see its thin atmosphere, stripped away by solar winds, we are reminded of how precious our own atmosphere is, how easily it could be disrupted. When we imagine its lost oceans, we are reminded that Earth's oceans are not eternal gifts, but systems that must be protected. To look at Mars is to look at ourselves. It reflects both our hopes and our fears. It shows us the heights life can reach and the depths to which it can fall. It forces us to ask not only whether we are alone, but whether we will endure. This is why the question of uniqueness matters. If life is common, then we are not the only story. We are a chapter in a cosmic library, one among many. If life is rare, if Earth is an exception, then our responsibility grows heavier. We may be the only witnesses of the universe capable of reflecting on itself. That thought is both empowering and terrifying. It means that our survival is not just about us. It is about preserving awareness itself, consciousness itself, in a cosmos that may otherwise remain silent. These reflections stretch beyond science into philosophy, even poetry. For the people who dream of settling Mars, the planet offers more than a frontier. It offers a stage to rethink what it means to be human. A settlement there would not only test technology but also culture. What kind of society would grow on a world where every breath must be engineered, where cooperation is not a choice but a necessity? Would we carry our divisions across the void, or would the vastness of space remind us to be one species, fragile and united? Perhaps that is the greatest gift Mars can give us. Perspective. From its surface, Earth would appear as a pale star in the sky, a reminder of how small and delicate our home really is. To stand on Mars and look back at Earth would be to feel both distance and connection, loss and love, vulnerability and strength. Even without human footprints, the idea alone changes us. To think of microbes hidden beneath Martian ice is to imagine neighbors we have never met. To think of fossils in Martian stone is to imagine stories written long before ours began. To think of life that once thrived and then vanished is to imagine our own fragility in sharper terms. And so we continue to search. Each mission is not only a scientific endeavor but also a meditation on meaning. Every drill sample, every atmospheric measurement, every photograph of layered rock is part of a much larger reflection. What does it mean to be alive in a universe where other life may exist? If one day we do find proof, the reaction will be awe, but also recognition. We will not only be discovering something new, we will be rediscovering ourselves, rethinking what it means to live on this planet, what it means to share the cosmos. Until then, Mars keeps its secrets. Its deserts stretch in silence. Its canyons wait in shadow. Its ice lies locked beneath dust. Somewhere in those quiet layers may rest the answer, whether in the shape of a fossil, a trapped bubble of gas, or a hidden microbe asleep in salt. It is a strange comfort, this not knowing. It lets us dream. It gives us space to imagine, to hope, to wonder. Perhaps certainty will come with the next rover, the next mission, the first human step. Or perhaps the mystery will linger for generations. Either way, the search itself becomes part of who we are. And as you picture that distant planet tonight, glowing faintly in the sky, imagine the dust slowly shifting with the wind. Imagine the stones lying still, holding secrets billions of years old. Somewhere, beneath the red surface, the story is waiting, quiet, patient, untouched, waiting for us to listen.